Hi, my name is Samantha, and I'll be explaining number 3 from the 2010 BC test. The problem states that a particle is moving along a curve so that its position at time t is x of t comma y of t, where x of t equals t squared minus 4t plus 8 and y of t is not explicitly given. Both x and y are measured in meters and t is measured in seconds. It is known that dy over dt, or y prime, is t times e to the power of t minus 3 minus 1. And in part A, we are supposed to find the speed of the particle at time t equals 3 seconds. So since we're given x of t and y of t, we can assume that we're working with parametric equations, and the parametric speed is the absolute value velocity, or speed equals the square root of x prime of t squared plus y prime of t squared. And in the question, we're given that x of t equals t squared minus 4t plus 8, and y prime of t, or dy over dt, equals t times e to the power of t minus 3 minus 1. Now that we have y prime of t, we just have to find x prime of t, and that would just be deriving this to get x prime of t equals 2t minus 4, just using the simple power rule. And now we have x prime of t and y prime of t, so we just have to plug it back into the original speed function for parametrics. And we have the square root of 2t minus 4 squared plus t times e to the power of t minus 3 minus 1 squared. And this is x prime of t squared plus y prime of t squared. And we're finding this at time t equals 3 seconds, so I'm going to be using my TI-84 plus and just plugging in t equals 3. So we're taking the square root of 2 times 3 minus 4 squared plus 3 times e to the power of 3 minus 3 minus 1 squared. And our answer is speed equals 2.828 meters per second at time t equals 3. So writing that down, we have at time equals 3, speed equals 2.828 meters per second. And according to the scoring guidelines, part A of number 3 is only given 1 point, and that is for having the correct answer. But I would recommend also including the correct units, 3 decimal places, and the function for speed to really demonstrate that you know what you're doing. In part B, we need to find the total distance traveled by the particle from 0 to 4 seconds. So in parametric equations, we could look at this graphically first. And this is the graph of your speed. So this line represents speed. And we're going from 0 to 4 seconds. So at 0, we have the position. And if we look from 0 to 4, if we were to highlight this, that would be the total distance traveled because we're looking at a range of time. However, if this were velocity rather than speed, this is actually displacement, so make sure you're taking the integral of speed rather than velocity. So we're just going to be integrating from 0 to 4, our speed function, which is x prime of t squared plus y prime of t squared. So that would be 2t minus 4 squared plus t times e to the power of t minus 3 minus 1 squared dt. Don't forget your dt because we are integrating. And once again, we just have to use your calculator. And to integrate, I'll zoom in first, you have to press math and then 9 because 9 allows us to take the integral. And this is from 0 to 4 of the square root of 2x or t minus 4 squared plus t times e to the power of t minus 3 minus 1 squared. Now this part might take a while because we're integrating a somewhat complex function, but the final answer should be 11.587 or 11.588. So that's the total distance traveled, and we can write 11.588 meters. And according to the scoring guidelines, this question is given 2 points. 1 is for having the correct answer, and 1 is for having the correct setup of the integral. But once again, I would recommend having the correct units, 3 decimal places, and maybe even including a graph to show that you know what you're doing. In part C of number 3, we are asked to find the time t between 0 and 4 when the line tangent to the path of the particle is horizontal, if the direction of the motion of the particle is to the left or to the right at the time, and give a reason for the answer. And number 1 is pretty unique because we need to combine our knowledge of AB tangent lines with knowledge of BC parametric functions. And from AB we know that the slope of a tangent line is dy over dx. But we also have to consider time, so it's actually dy over dt divided by dx over dt. And these two are equal because when you divide, the dt's cancel and we are left with dy over dx. To find the horizontal tangent line, we have to set the numerator equal to 0 while making sure that dx over dt or the denominator does not equal 0. And so dy over dt equals t times e to the power of t minus 3 minus 1, and this equals 0. We can find t by graphing this. So we have y equals, I'm going to use x times e to the power of x minus 3 minus 1. And the window is from 0 to 4. And we have to pass through 0. Negative 10 to 10 works. We graph this. And we can see that it passes through the x-axis once between 2 and 3. So we can trace this by doing second trace, 2 for 0. Set the left and right bounds, make an approximation, and our answer is 2.208 seconds. So we can write that down. T equals 2.208 seconds, where there's a horizontal tangent line. Now I have to find if the direction of the motion is to the left or to the right, and to find that we have to see if dx over dt is less than or greater than 0. So dx over dt equals 2 times e to the power of 2 times t minus 4, and we substitute t with 2.208, so it's 2 times 2.208 minus 4. And that equals 0.416. And since 0.416 is greater than 0, we can write it's moving to the right, because dx over dt is greater than 0. In part D, there's a point with x coordinate 5 through which the particle passes twice. Find each of the following, including the two values of t when this occurs, the slopes of the lines tangent to the particle's path at the point, and finally the y-coordinate of the point given that y of 2 equals 3 plus 1 over e. We can start off with number 1, where we're finding where t is when x equals 5. So x of t equals t times t to the power of 2 minus 4t plus 8. We just set that equal to 5. And this is very, very basic algebra. We just move the 5 over, t squared minus 4t plus 3 equals 0. Factor it out, t minus 3 times t minus 1. And t equals 1 and 3 seconds when x equals 5. Very easy. Now we can move on to part 2. Part 2 is asking us to find the slopes of the lines tangent to the particle's path at the point. So now we have to consider dy over dx, and that's just t times e to the power of t minus 3 minus 1 over 2t minus 4. And we're substituting t with 1 and t with 3 from part 1. Just use your calculator, and we have 1 times e to the power of 1 minus 3 negative 2 minus 1 divided by 2 minus 4 is negative 2. So the slope is 0.432 at t equals 1. And we can do the same thing for number 3, but that's just very basic. I'll show you it's just 1. So that's number 2. It's quite simple once again. And number 3 is the harder one. The y-coordinate of the point given that y of 2 equals 3 plus 1 over e. And in this part we have to use the fundamental theorem of calculus, where this integral from 2 to 3 of dy over dt equals y of 3 minus y of 2. We know that y of 3 equals y of 1, so we can just use y of 3. And y of 2 is given, so we just rearrange this, so y of 3 equals the integral from 2 to 3 of dy over dt plus y of 2, which is 3 plus 1 over e. And once again, we use our calculator, take the integral, so math 9, I'm going to zoom in, and it's from 2 to 3 of dy over dt, which is x times e to the power of x minus 3 minus 1 dx. And a lot of people forget to plus their y of 2, but we won't do that. You just do plus 3 plus 1 over e, and our answer is 4. So y of 3 equals 4. And that's all 3 parts of part D. First point, according to the scoring guidelines, goes to having the correct t-values. Secondly, we have the correct slopes. And finally, we have the correct y value.